Creating a humanoid robot that mimics human form and function is a very complex process, and it involves several key engineering and scientific disciplines. Now, in this video, we are going to see how we can create, not we, but a humanoid robot is created in the labs. Of course, there are a lot of process and breakdown. First of all, we can always create a virtual companion in our with the AI tools, perhaps, but that's a different story altogether. And making a robot or creating a robot, humanoid robot, is a completely a different story. First of all, design and planning. Number one thing, biomechanical analysis is very important because researchers study human anatomy and movement. That means biomechanics to understand how joints, muscles, bones they work together. This knowledge is crucial for designing the robot's skeletal structure and movement mechanisms. Next comes conceptual design. Engineers create detailed 3D models, three-dimensional models of the robot, defining its size, shape, and range of motion. And decisions are made about the robot's intended purpose. That means which influence its design and capabilities and a lot of other things also. And material selection is also very important because materials are chosen for their strength, weight, and durability. Why strength, weight, durability are important uh, because the technicians or engineers they don't know how he will use this robot partner, whether he will use it for running, jogging, walking, or something else. They don't know. They simply don't know whether he will break that robot on your bed. They don't know. So lightweight metals like aluminum, titanium, these are used for skeletal frame, and polymers and elastomers for skin and outer coverings. Now comes the mechanical construction part because skeletal structure, just like us, is very important. A framework is built to replicate the human skeleton, providing support and attachment points for actuators and sensors. Now, what are actuators? Actuators are motors. Actuators provide the robot's movement. Otherwise, robot cannot move. Common types include electric motors or precise and controlled movements. Hydraulic actuators are used for high power and strength so that it can just uh, fight with you inside your bedroom kind of things. And pneumatic actuators are for flexible and compliant uh, movements. And there are joints. I created a lot of videos on just different types of joints of robots: leg joints, hand joints, finger joints, etc. Engineers design joints that mimic human joints, allowing for a wide range of motion. Hands and feet also very important because these are complex components that require intricate design to enable grasping, manipulation, stable walking. Grasping is very important because you don't know uh, you don't know what they will grasp and how they will grasp it. Okay. And then comes electronic systems, sensors are very important because cameras for vision, they don't have eyes, they have something in their eyeballs. Of course, actually they are cameras. Okay. And microphones for hearing because they don't have ears like us. Tactile sensors for touch. You touch a robot and it will shiver, or it will just I don't know what it will do. Anyway, but tactile sensors are important because touch is important for any kind of physical activities. And then come accelerometers and gyroscopes, which are balance and orientation. Okay. So robot, you can just push it, so it can just pull itself up and keep its orientation and balance. Control systems is also very important. That means CPU. You know, a CPU in a computer, a central processing unit or microcontroller manages the robot's movements and actions. Software algorithms control the actuators based on sensor input. There are a lot of algorithms written for only for this purpose. And of course, there is power supply because batteries or other power sources provide energy for the robot's operation. Any kind of operation you can think of. Software and artificial intelligence also come after that because motion control, is basically is controlled by software programs that are developed to coordinate the robot's movements, enabling it to walk, run, and perform other actions. Now, of course, artificial intelligence (AI) is there. AI algorithms enable the robot to recognize objects and people, understand speech and respond to commands, learn and adapt to new situations. And finally, we come to human robot interaction, because software is designed to facilitate what? It facilitates basically natural and intuitive interactions between humans and the robot or the machines. So there are a lot of things that we need to take care of. There are key technological considerations that we need to keep in our mind while thinking of creating a robot from a scratch. Okay, so I will come back in my next video with detailed other things like why we need bipedal locomotion or dexterous manipulation or sensor fusion, why AI and machine learning are very important in this case particularly. Okay, so see you in the next video. Till then, goodbye, stay safe and take care.